Good evening, everyone. My name is Sherylynne Crookshanks, and I'm a junior at Fort Defiance High School. For my presentation, I looked into various solutions for reducing my high school's impact as a heat island, and I'd like to present to you Paint Before You Park. Now, before I explain my research, I'd like to go over a couple basics. A heat island is classified as an urban area that is significantly warmer than the area around it because the surface absorbs the sun's rays rather than reflects them. However, don't let the word urban fool you. Being from a rural area myself, I was curious about heat islands around my community. Come to find out that I didn't have to look too far because parking lots pose one of the greatest heat island problems of our modern world, which isn't surprising because of the asphalt's dark color. This led me to ask the question that became the foundation of my project and overall research. If asphalt was a lighter color, would its impact as a heat island be reduced? At Fort Defiance, our parking lot isn't quite normal. We have a tradition of allowing students to paint their parking spot for a small fee as a fundraiser to support our art department. Knowing this, I went out and tested the temperature of the various paint colors to see how they compare to the asphalt as well as each other. As you can see, the paint has significant impact on the asphalt's temperature. The most impactful result I found was the almost 11-degree difference between the asphalt and an all-white parking space in front of Fort's parking lot in the front. A similar trend was found in the idea that the lighter the color of the paint, the more the temperature got reduced, supporting the question that I asked as a basis for my project. Now, I know that looking at charts full of numbers might not be everyone's favorite pastime, so I created a color-coded chart as a visual aid. I matched the color of the column as best I could to the paint's color so there could be an accurate representation of what I was working with. This also provides an easier way to see how the colors compare to the asphalt as well as each other. For example, note how some paint colors, such as the dark blue, actually increase the asphalt's temperature rather than reduce it. I didn't find this surprising because I knew that dark colors absorb heat while lighter colors tend to reflect it. This is why, in my hypothesis and throughout my project, I focused on lightening the asphalt surface. After discovering the effect white paint had on a single parking space, I looked into what it would take to paint Fort's entire parking lot white. Now, with our parking lot being about 142,000 square feet, this could cost us anywhere from $19,000 up to $85,000. Now, I know this is a wide range, but the cost depends on the type of paint used, and the number of layers needed also depends on the type of paint used. It's all interconnected. To test my theory of a different number of layers having a different effect on the paint and the temperature, I performed a small experiment with two pieces of asphalt and white paint. I left one section unpainted and separated the other into three different sections, with each section having an added layer of paint. I placed the asphalt under a heat lamp for about 20 minutes before checking each section's temperature. The unpainted asphalt got up to 24 degrees Celsius, and the painted asphalt got down to 23 degrees Celsius when I tested the section that was painted with 3 layers of white paint. These results confirmed my second hypothesis of the more layers added, the more the temperature would be reduced. After I experimented with the white paint, I looked into alternate solutions that other researchers and scientists had come up with or looked into. I found out that asphalt actually comes in different colors, one of them being pure white. It would cost up to $273,000 for Fort Defiance to repave our entire parking lot. Another solution I looked into was Cool Seal, a water-based asphalt seal coat. It was used in Los Angeles' Cool Pavement project in 2015 and reduced heat emitted from the streets by up to negative 1.1 degrees Celsius or 30 degrees Fahrenheit. This seal coat lasts about 7 years and would cost my high school up to $100,000 to implement. For a final, simple comparison of the options for Fort's individual parking lot, we'll look into the price of each, how long they'll last, and a few basic pros and cons. Repaving with the pure white asphalt is the most expensive, being in the upper 200,000s cost-wise, but it would last about 20 years. Cool Seal, the asphalt seal coat, has been proven to reduce the heat emitted from parking lots, lasts about 7 years, and would be around $90,000 as a rough estimate. Finally, painting Fort's parking lot white could cost anywhere from $19,000 up to $85,000, making it the cheapest, but it would have to be repainted every few years and be able to withstand the various weather hazards we experience here in Augusta County. So, what does this mean for Fort? Unfortunately, we don't have the budget to work with solutions such as repaving our entire parking lot or using cool steel because of the large size of our parking lot. However, our tradition and fundraiser of allowing students to paint our parking spaces helps turn this fee into a fundraiser. For those of you in a school system or even a simple business, I challenge you to look into the possibility of painting your own parking lot. You could pose it as a fundraiser, like Fort Defiance, and raise money for your organization. If it seems simple, that's because it is. You'll be surprised at the impactful outcome that will result if you decide to join Fort Defiance in painting before you park. My name is Sherylynne Crookshanks, and thank you for allowing me to present today.